Now, in this chapter, we are going to learn the laws of motion. We'll start with the effects of force. What a force can do: force can change the shape of an object, the dimension of an object. Force can make a body moving at rest. Force can make a body who is at rest moving, so it can change the state of rest or of motion of the body. That is, it can produce motion in the body, and it can also stop a body which is already in motion. It can change the dimension of the body as well. It can change the size or the shape of the body. What is a force? A force is that physical cause which changes either the size or shape or the state of rest or motion of a body. SI unit of force is Newton. CGS unit of force is time, and the relationship between SI unit of force and CGS unit of force is 1 Newton equals to 10 to the power 5 dyne. You need to learn this because in order to convert dyne from Newton, Newton from dyne, you need to apply that formula. Now coming to the contact and non-contact forces. Contact forces. The forces which are applied on bodies by making a physical contact with them are called contact forces. For example, you basically hit someone with your palm. This is basically an example of reaction force. This is a contact force. Then we have some non-contact forces also. The forces experienced by bodies even without being physically in touch. For example, gravitational force, the attraction of earth, which is not physical in touch but it acts on bodies. These are example of non-contact forces. You can see some of the examples of non-contact forces. Magnetic force is a non-contact force. Electrostatic force is a non-contact force. You might have observed this while combing your hair. Newton's first law of motion. According to Newton's first law of motion, if a body is in a state of rest, it will remain in the state of rest, and if it is in the state of motion, it will remain moving in the same direction with the same speed unless an external force is applied on it. So let's suppose, for example, this is a football. It is now at position of rest. Okay, it will remain in the position of rest unless it is getting disturbed by an external force, which is the kick of footballer. Now, if the football is in motion, it will continue to be in motion unless until it is getting stopped by a footballer. So this is basically the Newton's first law of motion. Now, we need to understand the concept of inertia at rest and inertia at motion in order to understand the first law of motion. So, inertia of rest. What is inertia of rest? If a body is at rest, it will remain at rest unless an external force is applied to change its state of rest. This property of body is called inertia motion, as we have already seen in the case of football. Then we have another, and there are some other examples too, like when a hanging carpet is beaten with a stick, the dust particles start falling out of it. Another example, on striking the coin at the bottom of a pile of carom coins with a striker, lowest coin only moves away while the rest of the pack remain intact on the carom board. Then inertia motion. The body in the state of motion continues to be in the state of motion with the same speed in the same direction in a straight line unless an external force is applied on it to change its state. This property is called inertia of motion. That means if a body is in motion, it will tend to be in the motion until unless it is disturbed by an external force. For example, a cyclist riding along a level road does not come to rest immediately after he stops pedaling. Another example, when a passenger jumps out of a moving train, he falls because his body tends to be in the motion and suddenly he comes to rest. Now, linear momentum, P equals to mv. Linear momentum of a body is the product of its mass and velocity, and hence the formula of linear momentum is mass into velocity. It is a vector quantity. The SI unit of momentum is kilogram meter per second. The CGS unit of momentum is gram centimeter per second. And you can say, since it is directly proportional to the mass, so smaller the mass, momentum will be smaller. Larger the mass, larger momentum. Now coming to the change in momentum. Change in momentum is basically defined by the change in velocity because mass is going to be constant everywhere. So rate of change of momentum, the rate of change of momentum equals to mv minus mu by t equals to mass into acceleration. Newton's second law of motion in terms of rate of change of momentum. According to Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the force applied on it and the change in momentum takes place in the direction in which the force is applied. For example, this is the diagram which shows that force is being applied in this direction and the movement of rocket will be in the same direction. Acceleration will be towards the same direction. Now coming to the examples of second law of motion in daily lives. Few examples we can see: hitting a cricket ball by a bat, but first we should understand the concept that why does it happen. So the mathematical expression of second law of motion is F equals to delta P by delta T. It gives delta P equals to F into delta T. So a given change in momentum of a body can be brought about either by applying a large force for a small duration. For example, in hitting a cricket ball, hammering a nail, hitting the ping pong ball by a racket, etc., a required momentum is imparted to the body by applying a force of large magnitude for a short duration. The bat hit the ball with large magnitude but for short duration. This is basically charging the momentum. Okay. Another example, hammering a nail. Another example, hitting the ping pong ball by a racket. That means the momentum is basically transferred. Then we have another examples. On the other hand, in following examples, the momentum of body is brought to zero. Previous examples where we saw the charge of momentum, that how a cricket bat hit the ball and make it in motion, make it move. On the other hand, in the given examples, in this slide, the momentum of a body is brought to zero in a large duration so as to reduce the impact of force exerted by the moving body or on the moving body. Like for example, while we catch a ball, the cricketer will draw his hands as long as possible along the ball so that in order to avoid any injury. Similarly, athletes often land on sand after taking high jump in order to avoid any injury so that they could not harm themselves. Another example, when glass vessels fall on a hard floor, they break, but they do not break when they fall on carpet because the time duration is basically increased. Now the next law of motion, Newton's third law of motion, is to every action there is always an equal and opposite reaction. For example, a book lying on a table. So this is basically the weight of book. The book is applying force downwards to the table, and similarly table is also applying force upward in the direction of book. So for every action there is always an equal and opposite reaction. You are pushing a wall is also applying forces on your hands. This is why you cannot move a wall by an inch. Another example, motion of a boat moving away from the shore. Rocket motion, you can see motion of boat in water where boat is basically moving and shores are trying to keep it backward. Universal law of gravitation. This was also proposed by Sir Isaac Newton. The force of attraction between two particles because of their masses is called gravitational force of attraction. For the magnitude of this force, Sir Isaac Newton gave a law known as Newton's law of gravitation. According to Newton, the force of attraction acting between two bodies is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Means larger the distance, lesser will be the gravitational force, and larger the masses, greater will be the gravitational force acting on the bodies. You can see here the relation between gravitational force and the mass and distance between two bodies. So here we get, and hence we get the formula F equals to G into m1 into m2 by r square. Unit and value of universal gravitational constant. The SI unit of G is nm square per kg square. The value of G is 6.67 into 10 to the power minus 11 nm square per kg square. Gravitational constant G is numerically equal to the magnitude of force of attraction between two masses, each of 1 kg placed at a separation of 1 meter. Now we are going to study the acceleration due to gravity. The rate at which the velocity of a freely falling body increases is called the acceleration due to gravity. In other words, it is the acceleration produced in a freely falling body due to gravitational force of attraction of Earth. The formula of acceleration due to gravity, and this acceleration due to gravity is denoted by small g. So formula is G equals to Gm by r square. Here you can see the acceleration due to gravity. The speed at which the apple will fall out of tree will depend on the acceleration due to gravity. Usually it is taken as 9.8 meter per second square. Then the concept of free fall. In case if a body falls from rest freely from a height h under gravity, then u equals to 0 and acceleration a is replaced by g. Then equation of motion are v equals to gt, h equals to half gt square, v square equals to 2gh. In case 2, if the initial velocity of the fall of body is u, then the equation of motion will be v equals to u plus gt. Here u was 0, in this case u was 0, that is why v equals to gt, we written directly this way. Now h equals to ut plus half gt square, v square equals to u square plus 2gh. In the third case, if a body is thrown vertically up with an initial velocity u to a height h, there will be retardation. Then the equation of motion are v equals to u minus gt, h equals to ut minus half gt square, v square equals to u square minus 2gh, because basically acceleration due to gravity will decrease as the body is going upwards and upward. Next is mass and weight. What is mass? Mass is basically a measure of quantity of matter contained in a body, while weight is the force with which the earth attracts a body. So weight is a force, that is why it will be considered as a vector quantity, and mass is a scalar quantity. The SI unit of mass is kg, and since weight is a force, then the SI unit of weight will be Newton because it is a force. Now mass is measured by physical balance while weight is measured by spring balance. Mass is constant for a body and does not change with change in place. For example, if your mass at earth is 10 kg, it will remain same at moon. But if your weight is 10 kg on earth, it can vary from planet to planet, it can vary from space to space because of the change in value of acceleration due to gravity. Now gravitational units of forces. In MK system, the gravitational unit of force is kilogram force kgf, and 1 kgf equals to 9.8 Newton. In serious system, the gravitational unit of force is gram force. That's all in this lecture. See you in the next lecture. Till then, take care.